All right, what up, guys? Here is our quiz 4 review video. Sketch the graph of each function. So these are the furthest back, so the ones you might need the most review on. To sketch the graphs of these functions, what you got to do first is look at those notes and remember that we are looking at the negative or positive sign here and the negative or positive sign here. So we have a negative in front, but a positive x, a negative in front with a positive x value always has the same exact general shape. And what is that general shape? General shape will look like this. So you can get that from your notes that those are. So we know kind of before we start that the graph is going to look kind of like this. After we've done that, we want to get at least 3 coordinates. I always recommend plugging in 0 as one of your coordinates. And then the other coordinates, looks like plugging in 1, 2, and these kind of things will be good for this problem. You always just got to try a couple of things using your calculator. I don't know why I wrote 0. That was in advance. My brain. So 0, 1, and 2 is what I'm going to do for this question. I think 1, 2, and 3 always a good idea, but anyways, plugging in a 0 here. Actually, I think does it give you 0 again? I believe it does. Plug in 0, divide by 4, add 1. Yep, it does. And then plugging in a 1 will give you, looks like just a negative 1. And then plugging in a 2 will give you a negative 3. So you might want one more coordinate after that just to get another one, but I think we're probably okay. So you got 0, 0, we got 1, comma, negative 1, and then we have 2, comma, negative 3. So we have that shape kind of going here. Just to be sure, plugging in one more coordinate can't really hurt. If we plug in a 3, though, we end up at negative 7. So we'll be down here. But we can generally see the same shape coming out of it. So look, something like this. And it trails off. Please note that it never ever hits 1. This value right here is our end behavior. Whenever we have a question with end behavior, it is a good habit to get into. And I didn't put in the instructions, and I should have. I thought it had the instructions. We want to have those end behaviors. So we say as x goes to infinity. Remember that this is the right hand side, and then therefore the other one as x goes to negative infinity is the left hand side. So on the right hand side it's going down, and on the left hand side it is always going to be going towards this number for this problem here, the 1. So same exact idea for this question here. We just want to start off by noticing that we have a positive there and a positive there. So our overall shape will be looking like this. And then we, again, want to plug in our numbers. If we plugged in 0, 1, and 2 here, I think 2 is going to be too big of a number because of this plus 1. So I think negative 1, 0, and 1 is going to be a better choice here. If we plug in negative 1, looks like we get 1. If we plug in 0, looks like we get 5. And if we plug in positive 1, I mean, we're going to get a big number. We plug in positive 1, we get 18, 17. So we have negative 1, comma 1. We have 0, comma 5, and we got 1, comma 17. Again, you can just use your calculator for those numbers. If you're confused as to what I'm doing, just so I can show you at least once on the calculator where I'm getting those numbers from, is we're not doing t-tests and statistics. We're going to be doing 2 times 3 to the power, and I'm just changing that x to whatever this number is over here. So if I change it to a 0, plus 1, and then minus 1, plug it in, it tells you that it's 5. That's where I got my 0, comma 5. Likewise, if I go and change that 0 up to a 1, the answer will tell me it's 17. Could have also done these things by hand. 1 plus 1 is 2. 3 to the second is 9. 9 times 2 is 18. 18 minus 1, 17. So either way, we have this overall shape. Negative 1, again, is our asymptote. So that's what we're kind of going down towards here. So it just gets closer and closer to that line. Goes up like that. Not really the best graph. That actually fails the vertical line test, but good enough here. And behavior, as x goes to infinity, you always start with as x goes to infinity and negative infinity. Then you just got to say, hey, what happens on the right? What happens on the left? On the left here, it goes to negative 1. On the right, goes to infinity. Don't forget, you can also check your work for every single one of these questions on the calculator. So if you go to your calculator here and go to like y equals, for instance, you can do typing in the original question. So 2 times 3 to the power of x plus 1 and then minus 1. And then if you hit graph, well, sorry, if you just hit graph, it should end up looking like this. So there's that -1 I was talking about and kind of shooting off up there. You could even change the window to make it look identical to this if you really needed to. You could also get this table over here by hitting second table. And if you do that, you'll see, well, again, I had this set up for something different here, but if you hit second table, it'll give you that, again, that same -1, 0, 5, 1, 17. You get more coordinates if you really wanted them. Oh, just to show one more time, as you go more and more negative, you get closer and closer to -1. And in fact, the calculator can't even do the decimals correctly and just assumes that it is -1, even though it gets really, really close and doesn't ever actually touch. Okay. Whew, one question done. All right, second type of problem. Solve each equation. Logarithms not required, but they may be used if you prefer. I do not prefer to use logarithms when they're not required because it makes the problem longer / more difficult. So step 1 of questions like this is to make every single one of these guys have the same exact base. So that 1/16 and the 8th both have powers of 2. So this is going to be 1/2 to the 4 to the 3 minus 2m equals 2 to the 3rd. By the way, that 2 to the 4th and that 2 to the 3rd being 8, you get that again from the notes. You've got to have that written down, memorized, etc. Anytime you have a 1 over something else, it is a negative exponent. So we could have actually just written -2 to the -4 to start the problem off, but we didn't. For the next line here, we are going to be using distributive property. And finally, we have 2 to a power equals 2 to a power. So the powers must be the same. So -12 plus 8m equals 3. Add 12 to both sides. So literally adding 12. You don't need to show that work if you're comfortable with it. And therefore, divide both sides by 8. You get 8. 15/8. If you want to use decimals, you can. But I think no decimals is fine. And it just... I don't know if it's my handwriting or the Zoom or both. All right, so continuing on with this one, same exact idea. So that's like 6 squared, but it's a fraction. So we're going to rewrite it as 6 to the -2 to the -x divided by 6 to the 2 to the x plus 2 equals, and this is 6 to the 3rd power. Again, you just have to use your notes or end up having it memorized. Continuing on, I made room over here because we need to continue showing our work down here. We are multiplying, so 6 to the positive 2x, 6 to the 2x plus 4, 6 to the -6x. Anytime you have a division, you are subtracting the exponents. So this is going to be 6 to the 2x minus 2x plus 4. Now our exponents are identical. We can set them equal to each other. Furthermore, 2x minus 2x is 0. So we just get -4 is equal to -6x. Divide both sides by -6. And that reduces. Use your calculator if you need to. 2/3 equals x. You could have also just left it as -4 over -6. I still would have given you credit. That does not matter to me. All right, now rewriting each question in exponential form. These are supposed to be freebies. I really expect every single student to get these. They are 2-second questions. We just do that base to this power equals the inside. 17 squared equals m. Whole problem. You always start with this guy's our base. This guy's our exponent. That's our answer. Now we're already in the answer, so we have to rewrite. So this is going to be a log base 12. Again, you're always starting with that first number. Then you write the next number on the other side. 144 equals the exponent, -2. Done. And again, that loop, this to this to this. Always start in that bottom left-hand corner, moving around. Hopefully easy enough. Boom. Next page. Let's go. All right. So each one of these, we just got to use a calculator. So first two, the buttons are very, very obvious. Log is just this button. Boom. Remember, it means log base 10. You plug in the 1.4. You write the answer down. It's literally that easy. 0.146. 3 decimal places is good for me. This one, ln is right there. ln of 2.3. And you get 0.833. Make sure you round correctly. Log base 4 is a little bit different. There are a couple different ways you can get there. I think the easiest way is using the window key, specifically alpha, window, and log base is number 5. So alpha window 5, the 4, the 53, and you get 2.864. Approximately, by the way. These are not exactly equal, but that's all I got to do. It's literally free points. That was 5 free point questions in a row. I expect every student to get those right in the test. Please. All right, solve each equation. Now you actually have to do the work. So questions like this, all of these guys, we got to use the log loop in some way, shape, or form. So the first step is to rewrite. We got log base 5 of the other side is the exponent. So again, 5, 36, 10 are the same exact loop. And then divide both sides by 10. And that's it. That's all you got to do. If you notice, it doesn't even say in the question whether I need you to write as a decimal or an exact answer. I don't even care. If you really, really wanted to, you can go figure out the decimal answer for this, but there's no need for it. Actually, I want to see. Let's see the answer key. How did I put my final answers? For this one, yeah, I left it in exact form. So we actually don't even need decimals. No need for it. So if you want to practice your decimals, nothing wrong with it, but yeah, no requirement there at all. All right, let's go ahead and add 7 to both sides here. So the idea is you can't do your log loop unless you're in this form. This minus 7's in the way, so we got to add 7 to both sides first. Now we do our log loop. However, I made a quote-unquote mistake. The mistake that I made here is that I wrote log base e. We want to make sure we're using the correct notation. We never write log base e the same way we don't write log base 10. We write the shorthand version of it, which is ln. So we're going to write ln of 94 is equal to n minus 10. Then we're going to add 10 to both sides, and then we're done. Cool beans. Number 12. Let's go. Same exact idea. Subtract 2 on both sides first. By the way, you do not need to show that work. If you were able to do that in your head, I would much rather you do it in your head because that's better for you in the long term. Anyways, all right, so divide both sides by 7, log loop it up. We got log base 8 of 53 over 7 is equal to 8n plus 1. Subtract 1, divide by 8. Be careful when you're subtracting 1. You're not subtracting 1 from the fraction. You are subtracting 1 from the entire logarithm. So you got that minus 1 out there equals the 8n. So divide both sides by 8. Easy peasy. All right, number 13. Log base 8 of r equals 2. Same exact idea. 8 to the negative 2 equals r. You could stop here, but 8 to the negative 2 is something we could actually write down as a fraction in a correct way because it's the same thing as 1 over 8 squared, which is 1 over 64. So I think that's actually the better way to write that one. I'd probably still give credit for this one, but this is better. All right, number 6, same idea as these previous questions, but you need to rewrite them in the exponential format first. So we're going to divide both sides by 6 to start this question off. And then we have this guy to this power equals this. So we got 4 to the 4 equals n minus 3. 4 to the 4 is one of those numbers on our list. It is 256. Add 3 to both sides, you get 259. Dope. All right, last one. This one is very easy to make a mistake, so you've got to be careful. There's this tendency for students to immediately see 5 minus 9 and write negative 4. It is not, because we have PEMDAS here. The idea is the 9 gets multiplied to the logarithm before it gets subtracted. So what you actually want to do is you want to start by realizing this is a positive 5 and subtract 5 on both sides. So be very, very careful when questions are set up like this. It does trick students quite often. Now we're going to divide both sides by negative 9. When we divide both sides by negative 9, it comes out to a nice, pretty answer of 4 over here. Remember, there's an invisible 10 here if it's not written. So we got 10 to the 4 is 8n plus 3. You can even put the 10 in there if you really wanted to. 10 to the 4 is 1, 2, 3, 4. There, decimal, and then we are subtracting 3 and dividing by 8 is equal to n. So that's 9,997 divided by 8. We are all done. Good luck on this quiz on Friday, guys, and have a wonderful rest of your day. Peace out.